This is Algebra 2, Unit 5-7. I'm so proud of you guys. We're almost done on this unit of square roots and cube roots. And how usable this stuff is. Okay, so now we're going to solve equations. Would you please just remember, I like the line drawn, the spotlight on the creepy dude, and write your PIMDAs. Your whole goal here is to get the root by itself first. I'll just tell you how much. Get the root isolated, then we can do a lot. Because as soon as the root is isolated, which this one is automatically on this one, we square both sides, and then we can get rid of that root, and it makes things really nice. So squaring a square root, we'll cancel it, cancel that, and we end up with x plus 2 equals 9. Subtract 2 from each side, and we have x equals 7. Now, always, always, always check these. So we plugged 7 in. 7 plus 2 would be square root of 9, which does equal 3. Okay? So let's try another one. Cube root, this time, of 12x. Well, you've got the root isolated, so let's cube it to get rid of that root, cube the other side. And now we have 12x equals 216. Now we would divide by 12 on each side. And we would get, I wish I'd grab my calculator. I'll just do it this way. If that is 6 times 6 times 6 over 12, I know that 6 goes in there once and 6 goes in there twice, 2 will go in there 3 times, so x equals 18. Okay, so now cube root of 12 times 18 should equal 6. 12 times 18 be 16, 36, 0, 8, 1, 6, 11, 216. Cube root of 216, check it out, is 6. And if you want to check that on a calculator, you plug in 216 raised to the 1/3. We talked about that before on rational exponents. My pins are scaring me here, so let's just hope that I make it through the end. Now again, on this one, the square root is not isolated, so our first thing, oh my lord, is to isolate it. So we want to get rid of that 5. So we'll have square root x minus 3 equals x minus 5. Our next thing is we want to square to get rid of the square root. Square here to get that. So this will cancel the square root. And we get x minus 3 equals x minus 5 times x minus 5. You can FOIL it, you can box it. I do it in my head anymore. First times first would be x squared. Negative 5x and negative 5x would be negative 10x. And negative 5 times negative 5 being the last ones would be 25. Now we just set it to 0 because we've got 3 terms. So we add 3, subtract x. Ooh, that's going to make it hard for you guys to see. That light went out and my pin's dull, so we subtract an x here. Okay, I just got to take a pause. Be right back with a good pen. Sorry about that. So we add 3, subtract x, subtract x under the x term, add 3, and we get x squared minus 11x plus 28 equals 0. Now, how would you solve that? Hopefully you would say x game factoring. You are correct. Because we have a 1 here, we can just look at this and say what two factors would multiply to be positive 28 and add to be negative 11. I'll go ahead and play the x game for you guys that haven't been in my classes. 28 that have to both be negative to make this positive. And the only two factors that we can think of is 7 and 4. Since this is a 1, we can go straight to our answer. X minus 7 times x minus 4 equals 0. Now we have to find what x would be. We set each of these to 0. So x minus 7 equals 0. So x would equal 7. X minus 4 equals 0. X would equal 4. Now I need to erase some of this because you got to see what happens when we plug these in. So our answer is 7. 7 minus 3 is 4. Square root of 4 is 2. 2 plus 5 is 7. Okay, now we look at the next one. Square root, x minus 3, this answer being 4. 4 minus 3 plus 5 equals 4. 4 minus 3 is the square root of 1. Plus 5 equals 4. 1 plus 5, does that equal 4? No. We call that extraneous solution. Now you are getting into problems where theoretically it might work mathematically, but it doesn't actually work out when you plug it back in. So you always have to check your answers to find where the extraneous lies and where it doesn't. Common and square roots. Okay, so now we solve this one. We have cube root. Again, you want to get the root by itself first. So we would draw our line, subtract 3, we're going to up the PIMDAS, subtract 3, we'd have 2 times x minus 8 cube root equals 2x minus 4. Now we divide by 2, divide by 2, divide by 2. We get cube root x minus 8 equals x minus 2. Now we want to cube it. So that'll cancel there. We get x minus 8 equals, let me show you how I do that, x minus 2, x minus 2, whoops, x minus 2. If you remember Pascal's triangle, you could use that because I have students that weren't in here for last block. I'm not going to go to that one. I'll just show you how to FOIL these. So we get x squared minus 4x plus 4. Now you need to multiply that by x minus 2. X times x squared is x cubed. X times negative 4x, negative 4x squared. X times 4, positive 4x. Negative 2 times x squared, negative 2x squared. Negative 2 times negative 4x, positive 8x. Negative 2 times 4, negative 8. Add these together, x cubed minus 6x squared plus 12x minus 8. Okay? So that goes right over here. X cubed minus 6x squared plus 12x minus 8. And we would get rid of these on this side, set it to 0. Minus x plus 8 And hopefully I have a blank board here that I can use. I do! Let me transfer this. So now we've got 0 equals x cubed minus 6x squared plus 11x. And the 8's cancel. Okay, let me make sure that that looks right. Something looks a little bit funky. Okay, negative 4x4. That was 4x. Negative 2x positive, negative 8. Okay, I think everything's right. So we have plus x, minus x. Okay, we'll see how it rolls. Okay, so now the first thing that I would do is I would factor out an x because they all have x's. So now I have x squared minus 6x plus 11, and I have something funky here because we should be able to factor that down. So let me go back and check real quickly. I'm sorry to waste your time here. Help me spot it. X minus 2 cubed, x squared minus 4x plus 4, x minus 2, x cubed, oh, no, that's right, plus 4x, It should be factorable, and it's not, because 11 doesn't have factors. Let me run grab my key really fast and see if I can spot what I've done. I hope you guys caught it. Actually, you wouldn't have caught it. It is right here. My mistake is that that's an x squared. An x squared, okay? So we would be subtracting it from the x squared column. So we would end up getting a negative 7 x squared, and that 12 would remain. So it's just a typo, sorry about that. Okay, so now what two factors would multiply to be 12 and add to be negative 7? Hopefully you said it would be negative 4 and negative 3. We have to set each of these to 0. So x equals 0 would be one of our answers. X minus 4 equals 0, x would be 4. X minus 3 equals 0, x would be 3. Now, because of extraneous solutions, we need to plug each into their original equation, which we can't forget, that was an x squared. So it's 2 cube root x squared minus 8 plus 3 equals 2x minus 1. So I just start plugging things in. 0 squared minus 8 plus 3 equals 2x minus 1. That x is 0. Okay, and this is a cube root. So the cube root of negative 8 is negative 2. Negative 2 times 2 would be negative 4. Plus 3 would be negative 1. 2 times 0 is 0, minus 1 is negative 1. So 0 checks. Leave that in your work so that I can see it. On this board I'm out of space, I've got to erase it. Now I plug in 4. 2 cubed. 4 I don't mean 2 cubed, cube root. 4 squared is 16 minus 8 is 8. So cube root of 8 is 2 times 2 plus 3. And on this side we have 2 times 4 is 8, minus 1 is 7. So 4 plus 3 is 7, 8 minus 1 is 7, so the 4 also checks. Okay? Let's go to the next one. Again, leave your checks there so I can see them, they mean a lot. 2 cube root 3 squared minus 8 plus 3 equals 2, 3 minus 1. Okay, 3 squared is 9, minus 8 is 1, cube root of 1 is 1, times 2 is 2, plus 3 is 5. And 2 times 3 is 6, minus 1 is 5. So all 3 of those check. That's highly unusual in some of these problems, but let me just double check. Again, boy, I apologize, but I am getting a little bit tired, so I need to double check. Yeah, that is what I got. They all 3 work in that situation. Okay, so be ready to do this in class. Thank you, guys.